Alright, let's pick it up. Chem 110B, Chapter 9, Solutions with Reactions this time. These are beakers with ice. Beaker problems with ice tables. We've talked about ice tables in class. We're going to go over them some more here. Pages 153 through 157 are where this concept is first explained. We're doing examples, exercises 9H, numbers 1 through 14. Couple of brief facts to have to be remembered here. The reaction, if given, means ice table setup. You have to be aware of that if a reaction is shown, it's a different setup than if there's no reaction. Remember, no reaction problems, we set up moles along the edges and then add them up. But whenever we have a reaction problem, there's ice tables. And because it's a reaction, some of the reactants is going to get used up. Somebody's going to be the limiting reagent. Somebody's going to be the limiting reagent, which means their final concentration has to be 0. One of the reactants, at least one of them, has to end up with a 0 molar concentration at the end. So, our job is to go through the process. Remember, concentration in moles per liter times volume in liters, we're going to have to do that calculation to find out the moles, and then we're going to keep track of the moles. So let's go through our business the same way we always do, this time with ice tables. Okay, here's our problem. We've gone through this before. You tell me if you can do this problem on your own. Hit pause, give it a try, come on back. Okay, let's see where we're at. Remember, sig figs are going to be really important here, so be careful. Alright, what are the ion concentrations in a solution made by mixing? Here we go. 28 milliliters of 0.42 molar NaCl is mixed with 34 milliliters of 0.45 molar silver nitrate. They want to know all the ion concentrations at the end. And they give us the reaction. The chloride ion from this beaker reacts with the Ag plus from this beaker to make AgCl solid precipitate. Alright, so what do we got going here? Final volume. Easy enough. 28 plus 34, 62 milliliters. What else? Easy. AgNO3 means Ag plus and NO3. Same concentration in this beaker, which is 0.45 molar, because it's a 1-to-1 ratio. 1-to-1 ratio here too, so life is sort of good so far. The Na plus is the same as the chloride, which is 0.42 molar. I hope you can zoom in on that, make that full screen so you can see it. Sorry if it's small. Okay, so that means, what do we got here? We've got to find the sodium ion, chloride ion, silver ion, and nitrate ions concentrations at the end. Okay. Remember, there's no moles in adding them up, because what happens here, the chlorides and the silver ions lump together to make the silver chloride. Net ionic equation takes the chlorides and the silvers out of solution to make the silver chloride precipitate. So what we do instead is we do ice table. I stands for initial, C stands for change, and E stands for end. That's where the ice table comes from. And we're going to keep track of the moles up on top. So let's do moles of sodium ion here, and then we'll do moles of chloride ion here in the first beaker. then moles of silver ion here, and moles of nitrate ion here. We are not being asked, nor do we have to worry about the silver chloride at the end, because we are only dealing with the ion concentrations in solution. The AgCls that are in the precipitate are not in solution. Okay. So, we have to figure out the moles of the sodium ion and the moles of the chloride ion in this first beaker, and the moles of the silver ion and the moles of the nitrate ion in this beaker. Can you understand that because the concentrations and the volumes are the same, that this value will be the same for both? Okay, so let's do that first. This is A, and this is B. So let's do our calculation for A right here. A says 0.42 moles of the sodium ion per 1 liter times 0.028 liters gives me, to 2 sig figs, .0.01176 or 0.012 moles of the sodium ion initial, which is equal to moles of the chloride ion initial. It's really important that you know exactly what you're calculating here. 0.012, 0.012. Good. Now let's find the moles of the silver ion and the moles of the nitrate ion. 0.45 moles per 1 liter times 0.034 liters .45 times 0.034 cancels out, and we get 0.015 moles of the silver ion, 0.015 moles of the nitrate ion initial. Okay? 0.015, 0.015. Alright, so now we know what we start with. Alright, so what's the change? Well, the change is related exactly to the reaction. Notice that when you're making something, we use up the reactants, right? So any change that happens is going to be a negative. We're going to get rid of. And notice that we don't have anything over here in the product side. So we're not even keeping track of what's being made here. We're just interested in what's going on, what's changing in the reactants. Okay, since we're given the net ionic equation, and it only includes the chlorides and the silvers, hey, the spectator ions, which are the sodium ions and the nitrate ions, are still in solution, but they don't change. So we know that there's 0.15 moles of the nitrate ion at the end. And we know there's 0.012 moles of the sodium ion at the end. It makes sense, right? That's our definition of a spectator ion. It's present, but it doesn't change. But something definitely happens here. Why? Because the chlorides react with the silvers. And since it's a 1-to-1 ratio, what that means is, literally, if you had 12 frames and 15 wheels, how many unicycles could you make? Well, if you're making a 1-to-1 ratio, you're going to use up a smaller amount, aren't you? for both. It's a 1-to-1 ratio, so that's how many moles of the silver ion get used up, and that's how many moles of the chloride ion gets used up. 0 moles of chloride ion left at the end. That is our limiting reagent right there. Okay? Because we know it's the smaller amount, it gets all used up. How much got used up here? 0.012 out of 0.015. What's the results? Lining up the decimals and drawing the line gives us that many moles of the silver ion. That's good too. Okay, so look what we know. We know the moles of sodium ion at the end, the moles of chloride ion at the end, the moles of silver ion at the end, and the moles of nitrate ion at the end. They want to know the ion concentrations at the end, so what do we have to do? We have to divide them all by the volume at the end. 0.062 liters. 0.062 liters. 0.062 liters. 0.062 liters. Okay. So, taking this result and writing it over here, 0.012 divided by 0.062, 0.19 molar sodium ion, 0 molar chloride ion, 0.003 divided by 0.062 is 0.05 molar silver ion. 0.015 divided by 0.062 is 0.24 molar nitrate ion. Okay? I'm just showing you where each of the calculations came from. Alright, so does it make sense? The sodium ion and the nitrate ion only got diluted, right? We only just poured water together according to those because they weren't involved in the reaction. So the concentration of the sodium ion should go down by a little bit more than half, which it did. And the concentration of the nitrate ion should go down a little bit less than half, which it did. Okay, the chloride ion got all used up, 0 concentration at the end, and the silver ion got almost all used up, so there's very little left. You have to be careful in your significant figures rules with addition and subtraction here, because you can lose a sig fig in that answer. Now, the sodium ions and the nitrate ions are spectator ions, so they're still floating around at the end. There are no chloride ions that are floating around at the end. That doesn't mean there are no chloride ions in the solution, in the beaker anymore. They're just not floating around. They're all hooked up in that crystal cage with the silver chloride precipitate, and there's very few sodium ions floating around in solution. Instead, most of them are locked up in that crystal cage precipitate solid AgCl at the bottom of the beaker. Okay, you're going to see this on your next test, quiz 8. You're going to see it on the final exam too, so you better be ready for it. It's about being careful. It's about understanding that we're using an ice table for a reaction problem. Good luck. Practice up.